Alright, so at any rate, I'm going to make a new coil today, I think. And for that purpose, I have a little heat rod. My 0.7, can't tell. Hey, where is it in there so you can see it? No. That's not opening up now. I need to put it away for a while. Oops, there it goes. And I'm going to make a coil with that. Just to show that, well, I don't really use such high-tech methods of doing things. And I don't know, I don't think it's getting their battery in any way because of that. So I just make sure I have it locked up tightly at the end. And always when doing that, one should use some kind of gloves. You shouldn't do that this time. So really what it's all about is just making sure that you have enough of that wire, and then you just roll it around like so over this big old screw that I cut the head off. And sometimes tools of some sort that you can put them back in, keep them in order, so to speak, can be good. Yeah. So let's do this. Slightly tedious job, and with a 0.7 it's a fairly okay job, but I can tell you, well, actually I need to go back a bit and redo, I see, because I didn't pay much attention. Maybe I'm just too happy to be filmed, forget about doing things properly. Okay, here we go. So you should keep the wire like taut, so it doesn't fly around. You see, if you let it loose, it will obviously curl up because you have the tension in the wire that will do that. Just to illustrate, I can show you this thing here, and it is kind of wanting to get back to its original being. And so with this wire that I have here on the stick, So yeah. Now, if you're used to sitting at the desk all day long and hammering on keyboards and things like that, and don't often go out in the workshop and do some manual things like this, I think, or well, obviously if you do some sports that you do train the same muscles, I guess, but you will you will feel it in your hand, in the muscles of your hand. And this is just with the 0.7. Like I told you, with the 1 millimeters, it's like yeah, you kind of feel that you've done that afterwards. When you've done this a few times, you kind of get the knack of it, so you kind of do it fairly quickly. And so saying, yeah, let's see what we got. This doesn't seem to be quickly done still, I guess. Now, I have seen machines out there, the Martin Fleischmann Memorial Project, and at MP they have, well, Lenr, he has done some setup with a machine that is a really cool thing that does this perfectly, very quickly. And I don't really think the time is the essence of the essence in this case. I think maybe why they did that is more that you want to have the perfect coil, so there are no strange imperfections. Well, I guess imperfection, or imperfect, is my little name in this case. I do it like this, and just hope it works. Because I can't see any reason why any coil wouldn't be able to heat up. You have, of course, the durability of the coil that comes into question, but we have seen that and blown many coils. Actually, this is from my stock wire. This is my last coil I can make out of my 0.7. Let's see if I can get that straight out there. I have orders in there. There will be more wire coming in soon. It's just that I didn't really anticipate quite that consumption of this wire actually when I started. And hopefully, with my new test bed, I don't really have to worry much about that anymore. Because it seems to be working just fine and not harming the coil. But we have to see when we use an active reactor though. And this coil will be placed on what will be then the active reactor. The first run of that would be one run. I will do one run at least. I have to think about it, but at least one. Using again aluminum oxide mass, but adding lithium aluminum hydride in there to get the pressure up and get it to more mimic the situation that we are going to use it in. Run yet another calibration setup. Well, first a hydrogenation step, and then after that like a pure step function thing, a ladder just to see if it behaves in a similar way as the previous dummy. But I will play nice with that reactor, because when I've done that run, or maybe two, who knows, I will put in some active substance. I mean, I will put in some nickel powder in there, and the lithium aluminum hydride, and yeah, actually again some aluminum oxide in there. It seemed promising last time, and actually make a real run in a new test bed. So, and this will be the coil doing it. Isn't he looking just great? So, I've come to the end of the road, you might say. What I'm planning to do right now is then to actually anneal it, because, and that's why I'm kind of strung it up there with this thing here on the table, because if I let it go, it will curl up, right? And we don't want that to happen. You want it to be like 8 millimeters. And at that end, to that end, fix that. I will be then using a blowtorch to hammer it. I'm just going to wait for a few seconds to get that thing out of the way. So what I do is that I heat the wire up to some ample temperature, and you will say, well, what is that? And, you know, when it, to a point, I mean, if I take the wire in, you see it will begin to glow. Maybe you will see that it will begin to glow. It will begin to glow there. Yeah? So you don't want it to be bright yellow. You don't want to destroy it, you know. But you want it to be so you can kind of see just barely a red tone in the material. Now I have this set up in my vise, and that's a perfect conductor of the heat, so it does take some effort. It's easier out here to get it done. Also, the stick in there is also steel, so it's kind of, you need to heat the entire body up, so it takes some time to do that. Now, I'm no pro metal worker guy, so I don't know how much I must have. I just, you know, from trial and error, this is the way I do it, and it works for me. So maybe one of you guys out there who does know about these things will go Baha Humbug, and I would have been done here basically. But my experience tells me otherwise. Let's crank this thing up a little bit and be done with it. When you have been patient and actually done it in a systematic way, if you go in and try to heat it a bit, you can see that it will kind of get red a little bit. Of course, it's most difficult in here. I'm not sure if the camera can pick that up, but it's getting to get a bit reddish in a certain thing. And we need to go into the beginning of this thing because that's like a huge conduit for heat, so it will push the air. I think that will do it. Like so. Well, that's how I am making my coils. Like I tried to explain to you guys, I'm not an expert in this. Far from it, but presto, wow. Alright, let's see if we have slightly better temperature now. It doesn't feel warm to touch, no, like body temperature. It's running a light fever. Patient will not die. Okay, so then we are then done with our coil, so let's release it. There we go. There it is. All right. The next obvious step is then to put it in the reactor. That's it. We just have to then remove our coil, and that in itself can be kind of an exercise. Not so bad this time. I think it depends on how much annealing you have been doing on this. So, and as you see, even though I threaded this coil quite tightly, obviously I have the choice when applying it, spreading it out a little bit if I like, and experience tells you that, well, that might be a good way to not have it too tightly wind up there. The Coil handbook gives you some hints on what to do about that, and having them packed tightly, the wounds around, is, to my understanding, not recommended at all. So, but hey, you know, if you want something to happen, you need to be able to push the envelope, and so I try to have like a small separation, but yet not so much that my mallet tube doesn't cover it fully. That probably, according to the Coil people, is too small separation. As I found out now in my new test bed, things seems to be working fine, so I am going to do that. Yeah, now this is like a exercise in patience, if you so like, but actually this is going on quite smoothly, I think. I've had a whole lot more obstinate candidates for this, and this is a good one, I think. Yeah, now we have the coil on the tube. We just need to kind of ease it out. So now you see that if I hold it up a little bit, they seem to agree in size, and there is some separation, not much, but some. And I think it mimics the previous coil quite well.